All right, so if you were given this absolute value inequality, I asked you to solve it. So you could use your calculators to do this. However, it may be easier and quicker just if you understand the way that it's set up in the graphical form to identify the solution. Okay, and plus you're going to need to be able to interpret the graphical form anyway. So you need to have it written down, or at least, again, you don't have to memorize it, but you need it written down with your notes there to explain what you do. Okay, so if you isolate your absolute value expression, okay, so we're first going to isolate that, so we'll subtract a 2 from both sides. That gives us this new expression. Absolute value of x minus 5 is greater than or equal to 6. Okay, now all the pieces in here tell you something specific. Okay, so this number right here, if you take this expression and you find out what value of x equals, will make that expression equal to 0, that's going to be your reference point. Okay? So what value of x would give you a 0 in here? A value of 5, right? So that's a reference point. It's not going to come into play on the intervals itself. It's just the reference point for those. Okay, what does come into play is this number. Okay, so this number is the distance in each direction from this reference point that your graph is going to be located. Okay, so what's 6 units to the right of 5? 11. And what's 6 units to the left of 5? -1. So those are your actual two values. Those are the critical values that you're looking at. And then the only other thing that you need to do is interpret whether greater than means to split it apart or to sandwich it together. Okay, so again, I told you what those were in class last time, but the other way that you can think of it is if you go back to like the early days when you guys learned this, it was an alligator mouth, right? Did you guys do that, or has that changed? Still alligator mouth, right? Okay, so if you think of an alligator mouth coming toward this expression, would it be safer for, like if that was you and an alligator was coming toward you as a group, would it be safer to split up or stay together? Stay together? You guys all want to get eaten by an alligator? Split up, and it's the slowest person who gets eaten, right? So split up. So if the alligator mouth is opening toward that absolute value, okay, split. So the split, it means it's going to face the outside. Okay, and is the solution set going to contain these critical points or not? Is there an equal to? Yeah, so the equal to, and really you're just drawing an equal to, right? So if you draw a square bracket, you just draw the equal to and connect them. So equal to means you're dealing with that square bracket. And so this is what your interval would look like. And so if you had to express your solution here in an interval notation, you would write it -∞ to -1. Bracket here, never always a parentheses at the infinities. The next interval is 11 to infinity, always a parentheses at the infinity. We do include the 11 and a u in between to represent union of sets. You have multiple intervals that are solution sets here. Okay. All right, so if you can do that, again, you can either use the solve feature or set it up in this way. And the reason I talked about this is there will be times that you're just going to be given the graph, and you have to find several things about that graph. So if I gave you a graph that looked like this, okay, and I asked you first to find the inequality form of this. The inequality notation says what? X is between two values, right? So it's going to be sandwiched between two values. The values are -5 and 11. Are the -5 and 11 going to be included in there? They're square brackets, so it is included. So these will be equals. So this would be the inequality notation for that. Okay? However, I might also ask you to find the interval notation. If I ask you to find the interval notation for this, again, you take your lower limit followed by your upper limit, and then your grouping symbols to indicate inclusion or exclusion. Again, both of these are included, so you're going to have brackets here. I may also ask you a third way to approach this, and I might ask you for the absolute value inequality notation. So if I ask you to write this as an absolute value inequality, what you can do is if you understand this setup right here, what you can do is you can find it's going to fit the pattern of absolute value of x minus, again, our reference point. And then it's going to be some inequality symbol. So I'm just going to put an inequality right here. But it'll be greater than, less than, or greater than or equal to, or less than or equal to. Okay? And then you're going to say the distance from the reference point. Okay? This is called tolerance. Okay? So you have your reference point, you have your tolerance. Okay? And so if you were to identify the absolute value inequality expression for this, what would our reference point be? What's halfway between -5 and 11? Simply find the average. Right? Add them together and divide by 2. So if you took -5 plus 11 and divide by 2, -5 plus 11 is 6. Divide by 2, you get 3. Now, is it true that 3 is how many units from 11? Right? And 3 is how many units from -5? So it's consistent, right? Whatever that distance is your tolerance. So you now found your reference point and you found your tolerance. And so you can just plug it right in here, absolute value of x minus 3. And you're comparing it to 8. Now, the only other thing that you have to do here is determine, are you dealing with a greater than or a less than? Okay, which one was sandwiched between? Again, the greater than was the one that you split, so the sandwich one is going to be less than. And will it include these critical points as in the solution set? Yeah, it has the bracket, so it's included. So this would be your absolute value inequality. And now, I'm telling you this because you're going to get questions that'll ask you to write your answer in one of these 3 forms. Okay? And it might be different for each of you. So if the person next to you, if you happen to be peeking over there, see what they did, and they're writing an interval notation, yours might say inequality, or it might say absolute value notation, or absolute value inequality. So read carefully. It's going to be one of these 3. Okay? You'll be asked to write it in one of these 3 forms, but it'll vary from problem to problem, and it'll vary from test to test. And so be very careful on that. Okay? So in addition to this, and you may be asked to write the absolute value inequality form of, and I might give you either an inequality form or an interval notation. So what if I gave you this? Okay, so just see for a second, could you answer this question? Could you find what is the absolute value inequality form that gives this same interval, or this same set of intervals? It may be useful to sketch it and then identify. What's your reference point? What's halfway between 3 and 7? 5. 3 plus 7 is 10, divided by 2 is 5, so that's our reference point. So we already know our absolute value is going to be x, absolute value of x minus 5. Now, which inequality are we going to use if it splits? Greater than or less than? Remember, again, the split looks like the oars of a boat, so it's great or than, right? Again, a number of different ways to try to remember that. So it's greater than. Will it be greater than or equal to, or just greater than? Just greater than, right? They're parentheses, so they're not included in the set, and it's excluded. And then we find the tolerance. What's the tolerance? The distance from 5 to 7 or from 5 to 3. It doesn't matter which one you choose. They should be exactly the same, and it is 2. So that's our tolerance, and we have our solution.